Now that we've done a lot of graphing quadratics, it's time to go in the other direction. So we're going to be starting with a graph, and we're going to have to write an equation that represents this graph. So when you're looking at a parabola, the first thing you can look for are the roots, the point where the graph crosses the x-axis. But unfortunately, in this, there are no roots. This parabola is above the x-axis. So if there are no roots, we have to go to the vertex. That's another point we can use to write an equation. And the vertex we can see is right at that point right there. The vertex, that would be the point 2, 3 is the vertex. So now we have to remember the equation for the vertex form of a graph. It is a times x minus b squared plus c, where the vertex is b comma c. So this is pretty simple. We already have b is 2 and c is 3. So we can just substitute that right into this equation. So we'll have a times x minus 2 squared plus 3. Now the only thing we're missing is a. And in this one, we can very easily see what a is equal to. Remember that the coefficient on the outside here, this a, determines how steep the graph increases. And we know that in vertex form, starting from the vertex, when we move over to the left or right by 1, the y value will change by 1, and then it will change by 3, and then by 5, and you know that pattern by now. This pattern times whatever the a value is. So let's look at the vertex. What does y change by when x goes over by 1? Well, y just goes up by 1. So that matches the standard pattern, which means a is equal to 1. It is the standard steepness of the graph. So since a is equal to 1, it is just 1 times all of this. So we don't even see that. There we go. That is the equation of this graph. There is one more thing we want to do, though. We want to put it in standard form, the form ax squared plus bx plus c, since that is what you'll normally see a quadratic starting in. So if we did that, we're just going to simplify this out. This is going to be x squared minus 4x plus 4 plus 3. So the standard form will be x squared minus 4x plus 7. So that's going to be our final answer. So now if we were starting with this, we would just do this process in reverse, where we would convert it to the vertex form here, plot the vertex, and figure out that we would see that a here is 1, so we would draw this graph. Okay, now this one we also have no roots here. This parabola does not touch the x-axis, so we're going to have to use the vertex again, which in this graph is -4, -1. So now when we substitute that into the vertex form, we have x minus b here. So if b is -4, this will be x minus -4, which is x plus 4 squared, and c is -1, so we get -1. Now to solve for a here, first thing we can do again is see if we can figure it out just by looking at the graph. How much does the y value change when x goes over by 1? Well, here we can see the y value changes by -2. So it's that simple. A is -2. Because if we keep going, we should see that Since the standard pattern is 1, 3, 5, the pattern here should be -2, -6, -10. The whole thing multiplied by a of -2. So we should get down by -2, then down by -6, and we can see that right there, that we do indeed get down by -6. So a is -2. Now if we want to convert this to standard form, we just have to simplify this out. -32 minus 1 is -33. There we go. That is this parabola in the standard form of a quadratic equation. Okay, now this one's going to be a little different because here we don't have a vertex. We don't exactly know where that is. It's somewhere in between these points. But we do have two roots that we can easily see right here. These would be 2 and 3. So the roots are 2 and 3. Now we have to remember the root form. I'm not sure if I've given this formula yet, but this is the root form of a quadratic. A times x minus b times x minus c. And this makes sense because if you think about it, the roots are b and c. So the reason we have x minus the root is because we're saying what number do we need to set x equal to, so that when we subtract the root, we end up with 0, because remember, the reason it's a root is because y equals 0 at that point. By making either of these two terms 0, y is going to be equal to 0. So we just substitute in the roots for b and c, so we'll get a times x minus 2 times x minus 3. And now we have to figure out what a is. Now the problem here is that since we don't know exactly where the vertex is, we can't see exactly what the graph is increasing by when we move over by 1. We might be able to see it in here, but that's not, the vertex is starting somewhere over here, so we don't know how far into that pattern we are here. So when we don't have a clear vertex, we're going to have to calculate a algebraically. And the way to do that is to look at this equation and see that the variables that we have besides a are just x and y. So we can pick any other point on this graph and use the x and y coordinates from that and substitute into this equation. So let's just pick this point right here. We can see that right there we're right on the grid line. That's the point. The point is 4, 6. So now let's just substitute that into this equation. So we'll get y of 6 equals a times x of 4 minus 2 times 4 minus 3. So here we'll get 6 equals a times 2 times 1. So 2a equals 6. So we can see that a equals 3. So now that we know what a is equal to, we can put that back into this equation here. Remember, we want to be left with x and y just left as variables, so that way we could substitute points into the equation. And we're left with y equals a of 3 and times the root terms, x minus 2, x minus 3. And if we want to convert to standard form, we're just going to multiply these two terms together. And multiply that by 3. And there we go. That's the standard form of this equation. Okay, now in this one we have a choice because we can see that the vertex is clearly The vertex is clearly that point, and we can also clearly see what the roots are. The roots are clearly those points. So let's just do root form, since we've only done one of those so far. So the roots are going to be -1 and 3. So here is the root form equation. We don't know what a is yet, but the roots are -1 and 3. So since we're subtracting the roots, x minus -1 is going to be x plus 1, and then x minus 3. Now, can we figure out what a is without having to solve for it? Well, even though we're using the root form and that pattern we were using is meant for the vertex form, remember, because we know exactly what the vertex is right here, we can still use that pattern. So what does y change by when x changes by 1 in either direction from the vertex? Well, it looks like it's about 1/2. But how can we be sure it's -1/2? But how can we be sure that that is the correct value for a? Well, it would have to follow the pattern. So the pattern is, the standard pattern with a equal to 1 is 1, 3, 5. So this should be 1/2, 3/2, 5/2. So do we see that? Is that -1/2? Yes, it is. Is that -3/2? Yes, it is. -5/2, -7/2, and we can keep going. It's going to stick with that pattern. So even if you can't tell based on the first change in 1x what y changed by, just keep going and see if you can figure out the pattern. So we have just shown that a is indeed -1/2. And we will just convert this to standard form. There we go. Okay, now this one is a little bit different because we can see that we only have one root here. The graph is only touching the x-axis at that point. So when we substitute into root form, we have a times x minus the root of -4, so x plus 4. But it doesn't seem like we have a second root to use for this equation. Well, actually we do, because remember that even though it looks like it's only touching the graph once, this is actually a duplicate root. It's actually -4 and -4. The two roots are just right on top of each other. So we're actually going to have the same root twice, x plus 4 times x plus 4. So this is going to simplify to x plus 4 squared. But now, here's what you should notice. This one root is also the vertex. It's also where this graph starts. When you have only one root in a parabola, it is also the vertex. So this is in both root form and vertex form, because we can see from this form, maybe it'd be helpful if we added a +0 there. Now you can clearly see this is vertex form, the vertex being -4, 0. So because this is the vertex, we can use that pattern to find a without having to calculate it. What does y change by when x changes by 1? We can see that it goes up by exactly 3 to that point right there. So this is y equals 3 times x plus 4 squared. In standard form, there we go. Now here we're back to having two roots and this vertex here, we know it's going to be at an x value of -3 because the roots are 0 and -6, and the vertex is always right between the two roots. But we don't know exactly what the y value is going to be. So let's just start by using these two roots. The roots here being 0 and -6. So y equals a times, for -6, x minus -6 is x plus 6. And now x minus 0. Well, x minus 0 is just going to be x. So now in this one, because we do not know what the vertex is, we can't use that pattern to find how much it's increasing by, so we're going to have to solve for a algebraically. First, let's just simplify this a little bit to make it easier. X times x plus 6 will be x squared plus 6. So now we're going to substitute in x and y from any other point on this graph into this equation. So let's find a point that we can clearly see is on the grid line. How about that point right there? That is the point for 8. So substituting this in, we'll get y of 8 equals a times 4 squared plus 6. 4 squared plus 6 is 22. First, let's just simplify this equation a little bit. X times x plus 6 will be x squared plus 6x. So now we're going to use this point of 4, 8 and substitute that into the equation. So we'll get y of 8 equals x of, just redo the whole thing. So for this one, we're back to a graph where we don't know exactly what the vertex is going to be, but we do know, we can see that the roots are -6 and 0. We can tell that the x-coordinate of the vertex is -3 because it's going to be right between the two roots, but we don't know what the y value is going to be, so we're going to use root form. So the roots are -6 and 0, so we'll get x minus -6 is x plus 6, and x minus 0, which is just x. And we can simplify this out a little bit. A times x squared plus 6x. So now we have to solve for a, but since we don't know what the vertex is, we can't use that pattern to find out how much the y value is increasing. So we're going to have to solve for a algebraically again, which means we pick any other point on this graph that we can clearly see and substitute the x and y coordinates into this equation. So let's see if we can find a point right on the grid lines. That would be something like that one right there. 4, 8. So now we're just going to substitute y of 8 and x of 4 and simplify this out. This will be 16 plus 24, and we will get 40a equals 8, so a is 8 over 40, which is 1/5. So this makes sense. It's a fraction, and we know that fractions mean that since it's a very low number, that the increasing is very low. The y increasing is very low, so it's a much wider graph than what we usually see. Anyway, so now we're going to go back to this equation. Y equals a times x plus 6 times x. We know what a is now, so we can say y equals 1/5 times x plus 6 times x. Make it a little easier by putting the x right in front. So we'll just have 1/5 x times x plus 6. So this would be the standard way of writing it for the root form. But since we want the standard form, we're going to have to go one step further and just distribute this 1/5 x times x would be 1/5 x squared. 1/5 x times 6 will be 6/5 x. So that is the standard form. And finally, this time we can't tell exactly what the roots are, but we do see that the vertex is exactly on that point, 0, -4. So going back to the vertex formula here, we have the point 0, -4. So y of -4 equals a times 0 minus b squared plus c. So now in this one, we now see that we can't tell exactly what the roots are, but we can see that the vertex is exactly on this point, 0, -4. So going back to the equation for vertex form, we can just substitute the x value of the vertex is b, the y value is c. So we'll get x minus 0 squared plus c of -4. So x minus 0 is just x, so we can just rewrite this as ax squared minus 4. So what is a? Well, since we have the vertex, we can just look at how much y increases by when x changes by 1. So it looks like here it's somewhere between going up by 1 and going up by 2. But we want an exact number, so let's see if we can go over one more time and see how much we go up by. If we go over one more x value, now we're going up by what looks like, let's see, this would be 1, 2, 3, 4, 4.5 to get right there. So we went up 1.5, then 4.5. Well, the a value was how much we went up the first time, so it's going to be 1.5, or 3/2. Now the reason we went over one more was just to confirm that it was indeed 3/2, because if it is 3/2, then it should go up 9/2 after that, which it does. 9/2 again being the a of 3/2. This is the standard pattern when a equals 1, so this is all being multiplied by 3/2. So we get 3/2 then 9 over 2, 15 over 2, and on and on. Okay, so this is the vertex form. Again, even though it doesn't look like vertex form, this is what we normally look at as vertex form, but because b was 0, the x minus b squared, it just changed to x squared. But this minus 4 on the outside is what lets you know that it is in vertex form, because if we look at something, if we look at a root form, whether it's something like this, or whether it is something like this, we'll see that there's no numbers on the outside there. And this is also in standard form because we have ax squared, there is no b, so there's no bx, and minus c of 4. So this is the standard form and the vertex form. And as we saw with the previous problem, this form right there is the vertex and the standard form. Sorry, not the standard form. This is the, no, sorry, I'm getting confused now. This is the root form. This is the root form because we have roots are 0 and -6. This was the one. This one right here is vertex form and root form. We can see that the root is -4. It's a duplicate root. And we also see the vertex is -4, 0, because there's no c. Okay, anyway, don't get too wrapped up in the names of all of the forms. As long as you know how to convert between all of them, and the main reason for knowing that is so that you can do what we did in this video, which was use all of them to write equations of these graphs. So in the next video, we're going to be doing something similar. We're going to be doing the same thing, writing equations, giving points on a graph, except it's going to be a little trickier because we're not going to have an actual picture of the graph. We're just going to be given points that we know are on the graph.